the wood 70 to that Rosetta Stone. His red lips and twisted tone is heard the wind moan across the eaves. A battle with the fences, push on the trees, but never feel alone. Yes, 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 yes. Some original music out here right now, UCSB's Campbell Hall. Figured I'd play originals because so innovative here, you know? I want to show you a little bit of mine. This is a song I wrote when I was a gaucho, or still am always, but when I was back here at UCSB, taking classes in the English literature department. Well, them streets are wet with rain. It was raining in IV when I sang it. And everything, it seems the same. Well, even these words, they're gone creeping round in my brain. Oh, yeah, trying to find someone to blame. Just laugh away that day, good Lord, yeah. Ooh, snap the ball off the wrecking crane. All right. Snap it off, Lord, snap it off. Won't you just now take, for example, a day I couldn't cope. No, I had no money, couldn't smoke, no dope. Had chocolate with the vodka, flicking a coke, on made my head like a knotted rope. Just to make it worse, I broke the strings of my guitar, said, singing up the bell like to get me too far. Stumbled into bed, trying to clear static, but my city's so loud, thought I better inside the attic. Oh, didn't let me sleep, but kept me up all night. Body and my mind, 12 round fight. Just when I thought the bell would never ring, I remember a little song and I began to sing. If they are streets are wet with rain. Oh yes, and I have that thing, it don't seem the same. Even these words, they're gone creeping round in my brain. Oh yeah, I'm trying to find someone to blame. Well, I just laugh away that day. Step the ball off the wrecking crane, Lord. Snap it off, go snap it off. So I began to laugh. I was laying flat out in my bed. Gonna be alright is what the laughter said. And I closed my eyes. I fell asleep like I was dead. Right into a dream, laughing in my head, singing sometimes I'm slipping over the falls. Days closed out, I'm dropping right into walls. It don't hurt me none, try to drown me. Send me underwater, but to find a way to breathe. And there's some coming and screaming. Said singing about the blues, whole lot of feeling. I see myself as part of everything. And I opened up my mouth and I began to sing. If the streets are wet with rain. Oh yes, and everything don't seem the same. Even these words, they're gone creeping round in my brain. Trying to find someone to blame. Well, I just laugh away that day. Lord, yes, ooh, snap the ball off the wrecking crane, all right. All right, thank you. That's called Wrecking Crane. All right, this is a finger-picking song. It's called The Oil in Black. If I get a little more guitar, because this one's a finger-picking one here. Well, Tom's on his way home, but he's moving right through. Keep a tread on the oil and black, and he's singing them threadbare tunes. And his family knows, hey, this is how it goes. So much on the line and it's easy to lose. Moving along and singing away them blues. Well, 4 stars blank on a blackened hill. Hey, he's holding on to a dream. Thinks up a song that somebody else should sing. Well, maybe this one or that one will pay some of them past due bills. Think it's just a dream, but he's dreaming still. 'Cause Tom's on his way home, but he's moving right through. Keep a tread on the old and black, and he's singing them threadbare tunes. And his family knows, hey, this is how it goes. So much on the line and it's easy to lose. Moving along and singing away them blues. Well, the bar lets him out to that empty street. Hey, it looks like he's drunk as fill. He heads north and then he stumbles south, singing, I'm just doing this until I'm on the stage with the famous folks, playing a riff that the crowd all knows. It's better off as a dream, but I'm dreaming still. 'Cause Tom's on his way home, but he's moving right through. Keep a tread on the old and black, and he's singing them threadbare tunes. And his family knows, hey, this is how it goes. So much on the line and it's easy to lose. Moving along and singing away them blues. All right, a finger-picking song called Oil and Black. This next song, original, called Weapons. I said she left me in June. Oh, I make my mind a planetarium safe. Stars and comets and planets and moons. I ain't gonna lock every door to every room. My bed is stiffer with only me in it. Missing sounds surround the pit in my stomach, and my mind responds. All night dialogue. You're better off without her. No, wait and see what happens. You're better off without her. No, wait and see what happens. You're better off without her. Wait and see what happens. Oh, where did she find all of these weapons? I said, where did she find all of these weapons? And I cannot move. I'm at the event horizon. One way salvation and the other is ruin. And now outside my window say they fly by that fence. It 14 in its talent. All of the innocence that she left me in June. Make my mind a planetarium see. Stars and comets and planets and moons. I ain't gonna lock every door to every room. My bed is stiff with only me in it. Scene sounds around the pit in my stomach, and my mind responds. All night dialogue. You're better off without her. No, wait and see what happens. You're better off without her. Wait and see what happens. You're better off without her. Wait and see what happens. Oh, where did she find all of these weapons? I said, where did she find all of these weapons? Where did she find all of these weapons? And I cannot move. I'm at the event horizon. One with salvation and the other is ruin. And now outside my window say they fly by that fence. 14 in its talent. All of the innocence that she left me in June. Make my mind a planetarium said. Stars and comets and planets and moons. I ain't gonna rock every door to every room. No, no, no. My bed is stiffer with only me in it. Missing sounds around the pit in my stomach, and my mind responds. All night dialogue. Better off without her. Wait and see what happens. You're better off without her. Wait and see what happens. You're better off without her. Wait and see what happens. Oh, where did she find all of these weapons? I said, where did she find all of these weapons? Find all of these weapons, Lord, Lord, la, 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 la. I say, where did she find all of these weapons?
time the videos ends, the team will come up and you can just play along.
Okay, cool.
And then, yeah, pretty much that. Just every time here. So in black is you. So after every set of videos, you play. That's it.
Okay. Yeah, got it.
So fill your cart while I empty mine. Pull them on down the railroad line. See the rocks, Lord, all beneath our feet, yes. I say, Lord, no one to see, it ain't known to me. Well, these birds of prey got us paid, waiting on the failure of both our legs. Could be tomorrow, could be today. I say, Lord, 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 well, either way, we gotta keep on pushing. Don't take my eyes, fill your cart, take my arms, take my heart, so light my load, make it easier to move. I said, Lord, 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 ain't hold on to anything that I can lose, no. Take my eyes and fill your cart. Take my arms, on, take my heart. I said, light below, make it easier to move. I said, Lord, 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 ain't hold on anything that I can lose. So fill your cart while I empty mine. Pull them on down the railroad lines. Rocks, Lord, Lord, up beneath our feet. I said, Lord, 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 ain't known to see, ain't known to me. Well, these birds of prey got us paid, waiting on the failure of both our legs. Could be tomorrow, could be today. Lord, 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 well, either way, we gotta keep on pushing. Go, take my eyes, fill your cart, take my arms, take my heart, light below, make it easier to move. I said, Lord, 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 ain't hold on to anything I can lose. No, 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 ain't hold on to anything that I can lose. I said, no, no, ain't hold on to anything that I can lose. Thank you. Playing all original music. Kind of show you about my own innovation here. Inspired by my time at UCSB, all the great professors, all my friends, and people I met. A lot of this music comes from when I lived here in Isla Vista. But this song's when I moved down the street to Valerio. I thought it'd be better if I lived downtown and realized I couldn't really afford the bars anyway, so I don't know why I moved. I wanted to be all grown up. I was rolling down Valerio, had dead on my stereo. Burn a load of worries, oh yes, I blew them outside. But I still care that the world gone passing by. I can't get thoughts from piling up in my mind, oh, these times. But I see highlands suspended in blue. Sky could be water that I'm driving through, yeah. And every day's been flat. I've been drinking more and more. Get my feet outside the door. When I drive to the liquor store, Lord, Lord, as I want more. I want more. Said I want more. So I'm tapping out a rhythm. Oh, my truck's dashboard. So I go rolling down Valerio. I got Dylan on my stereo. Burn a lot of worries, Lord, Lord, I blow them outside. But I still care. World gone passing by. I can't get thoughts from piling up in my mind. Oh, these times. But I see islands suspended in blue. Yeah, sky could be water that I'm driving through. Yeah. I know there's everything on out there to do. My mind's no help at all, no thinking about nothing and they're telling me there's nothing to prove. But I see highlands suspended in blue. Sky could be water that I'm driving through. Oh yeah, I say sky could be water that I'm driving through. As I go rolling down Valerio, and Dylan on my stereo. Burn a lot of worries, oh Lord, I blow them outside. Yes, that I still care. World gone passing by. Getting thoughts from piling up in my mind. Oh, these times I see islands suspended in blue. Sky could be water that I'm driving through, yeah. I said islands, three of them suspended in blue. Sky could be water that I'm driving through. I let three of them suspended in blue. I said sky could be water that I'm driving through. I said islands suspended in blue. Sky could be water that I'm driving through. Islands suspended in blue. Sky could be water that I'm driving through. Oh yeah. Oh yeah. I said sky could be water that I'm driving through. As I go rolling down Valerio. Well, I dreaming down an old corridor. This could be an illusion. Well, I'm drawn to the girl at the store. She could be an illusion. So what is reality? Where is it from? Where are the light spectrum? What illusion? Drawn. And I sing to an uncrowded bar. This could be an illusion. And I drink another drink that makes four. This could be an illusion. So what is reality? Where is it from? Where are the light spectrum? What illusion. So what is reality? Where is it from? Where are the light spectrum? What illusion. Well, I dreaming down an old corridor. Well, this could be an illusion. Well, I'm drawn to the girl at the store. She could be an illusion. So what is reality? Where is it from? Wherever the light spectrum. Illusion. So what is reality? Where is it from? Wherever the light spectrum. Illusion. Thank y'all. That song is called Illusions.
Welcome to the 2023 UCSB Engineering Showcase. Thank you all for coming. My name is Tyler Susko. I teach the capstone course in mechanical engineering. I'm joined on stage by Matt Kostura. He seems to be our capstone musician. Every year is with us for this thing. He's an awesome UCSB grad. You'll hear from Alon Ben Yaakov a little bit later. You'll hear from Alon Ben Yaakov a little bit later, who's the electrical engineering capstone instructor. Today's a lot of fun. It's my favorite event of the year. We get to celebrate all the work that my students have done. These are all engineering seniors. They're going to go and graduate and leave us next year. But this is really their first full year project that they've undertaken. So I wanted to start the obvious place that you start with for engineering, right? Superheroes. So I went on to Bing, one of the search engines and one of the AI tools that's out there. And I said, give me an image of Batman and Superman flying on a black background, thinking there'd be two separate people. And this is what it came up with. So not exactly what I was going for. But the next superhero I asked for, was a standard, give me another superhero. And this is what it came up with. Not exactly what I was going for again. But this has superpowers of being super squishy, probably absorbing a lot of water, things of that nature. My favorite superhero is, as you can imagine, is Iron Man, right? The reason is Iron Man came up with his powers not from being on a different planet like Superman or getting bit by a spider like Spider-Man, but Iron Man gets his superpowers from being a really good engineer, right? And like any other superhero, if you haven't seen the movies, there's a cool origin story. So Iron Man is captured by the bad guys. He gets put into this cave and he needs to make his way out. And so, of course, what does he do? He builds a super suit so he can get inside of it and then blast through some walls, and now he can fight bad guys. But this is his origin story. And today we're celebrating the origin story of over 100 more engineers just like Iron Man. This is their first project that's launching them into their career, and then we hope that they're going to do many, many more afterwards. So today, you all hopefully have a program. If you don't, raise your hand. Our teaching assistants will be walking up and down the aisles and giving you one. Today you're going to see 4 pitches, which are on-stage presentations. There will be 2 or 4 videos from electrical engineering, 4 videos from mechanical engineering, and at the end we're going to give away 10 awards worth $20,000 to the students who have won in all these different categories. You as the audience get to determine 3 of these awards. 7 have been determined by a judging event that we had a couple days ago. But your audience here is going to be voting live for the best pitch that's on stage and the best video in each category. So if you don't have one of these programs, get one because there's a QR code to get to the voting website. I'll also be putting it on the slides. You just use your camera to open up the different websites. You go to the photography app, and you're able to find this website and vote. So I'll be putting that up later and giving you more instructions then. But I'd like to welcome our first team. The first team is sponsored by the US Navy. It's Team Gainer. This one kept falling down the whole time. I don't know. Every time I talk, it would fall off.
Everyone, my name is Daniel.
I'm Jacob.
My name is Xiangyun.
For the past couple decades, robotics technology has continued to define the capabilities and limits of humanity. From the exploration of other planets to the cleaning of radioactive sites. Robots have the advantage of not getting sick, operating 24 hours a day in toxic environments, and are replaceable. For these reasons, the US Navy has partnered with our team of UCSB engineers to explore robotics technology in the maritime environment. Research shows there's currently no robots designed to navigate the tight interior of a Navy ship. Thus, our team has developed the Gaucho Autonomous Navy Environment Robot, or GAINER, to redefine the standards of the maritime industry by introducing robotics technology to maintain the equipment that defends this great country, all while reducing cost and saving lives.
To maintain a Navy ship, our sailors need to perform a variety of dangerous tasks. This includes transporting live munitions, cleaning tanks with toxic fumes, and responding to emergencies, like fires on deck. These are all hazardous jobs that place our brave sailors directly in harm's way and can easily result in death. And a couple years down the line, our team recognizes the massive potential of replacing these sailors with robots that are better suited for this environment and don't have families they have to come home to. Thus, GAINER serves as a stepping stone inside of the process to make this incredible future a reality. But before we can even think about saving lives, we first need a robot that can properly traverse the Navy ship environment. So why hasn't this been done yet? Well, let's take a closer look at a Navy ship's interior. This isn't just a regular household hallway and door. It's a latching, weather-tight steel door at the end of a busy corridor. And here's what a staircase looks like. As if a 60-degree slope wasn't challenging enough, now imagine trying to climb up with this coming your way. With these challenges in mind, GAINER is specially designed to climb and descend steep staircases, open and go through latch doors, and engage with dials and switches, all while balancing in a constant shaking environment.
Here is what GAINER looks like. GAINER is powered by two motor systems sporting a drivetrain and wedges, which allows the navigation in different terrain. The multi-link arm and flexible gripper enable it to interact with different obstacles. As mentioned before, one of the hardest challenges is to balance the robot on a rocking platform. To be specific, if the center of gravity falls behind the last weight bearing wedge, the robot will fall backwards. To solve this problem, we add strong magnet onto each wedge to firmly secure the robot onto the stairs. We also took a further step to modify the center of gravity forward and downward by placing the motor in the front and adding a counterweight at the front. Those modifications enable GAINER to stabilize on the rocking platform. We use a PS4 controller to wirelessly control the robot. All the controller signal is sent to a Raspberry Pi, which dictates the drivetrain and arm movement. As a result, GAINER can interact with dials and switches adaptively, and even interact with the door latch. GAINER is more than just a robot. It's a life savior. With our robust mechanical and electrical design, GAINER can operate at a 1/3 scale, constant rocking shipboard environment, which provides the Navy invaluable solution to reduce the cost and save people's lives. Now let's switch to the live demo and switch to camera mode.
All right, so now I'm gonna give you guys a live demonstration on how we operate the GAINER robot. With the left joystick, I can move the drivetrain forwards, backwards, and I can also turn left and right on a tight radius. With the D-pad, I can control the robotic arm to go up, down, forwards, and back so we can interact with obstacles. The gripper can pitch up, pitch down. Oops, a little connection delay there. We can rotate, open, close, and rotate back to our position. Now we're gonna give you guys a demonstration on how we tackle the 60-degree staircase. Daniel's gonna flip this switch, and we're gonna start our shaking platform. There we go. So, I'm gonna start by activating our drivetrain forward, and we're gonna engage our magnetic treads with the staircase. Now that we're on the stairs, I'm gonna make some adjustments to the robotic arm to make an optimal center of mass for climbing. All right, now that we're firmly on the stairs, I'm just gonna modify the arm a little bit more, and we're just gonna let the robot do the work from here. All right, as we get closer to the top, a final little adjustment with the gripper here, and we're gonna prepare for our dismount. From here, the center of mass does the work for us, and we've successfully completed our obstacle. With what you just saw, it's the hope of our team that one day this technology will be used to save the lives of the brave men and women who serve our country. Thank you.
to get out there and start my research.
10 hours later.
Jeez, this takes forever. I wish there was a way to automate the process so I wouldn't have to spend so much time out here.
Hey, is everything going okay?
No, I just lost my house in the recession.
Not with that. Are you struggling to collect marine data?
Oh, yeah, that too.
Well, I have something that'll make your life a lot easier. Let me tell you about Ocean Pulse. Ocean Pulse is a proprietary network of buoys that collects real-time marine data and sends it to you instantaneously. With this network, you can obtain the data you need without all this hassle of deployment and maintenance.
Wow, is that legit?
Totally! Stop by our lab and check it out!
I need some help with my marine data. Are you guys Ocean Pulse?
Yes, we are. You've come to the right place. And now we'll show you how it works.
The Ocean Pulse system is made possible with our custom-designed turbidity sensor, as seen here. This sensor is used to measure the murkiness of water. It uses an LED light, as seen here, which is the light source that reflects off particles in the water and is measured by the 4 light detectors surrounding the LED. Here is an example of the readings of the turbidity sensor look like. We tested our sensor's accuracy by adding small increments of milk after each measurement. The lower the value is, the clearer the water is. As you can see, the voltage reading increases linearly with each increment of milk added. We have then mathematically modeled the relationship between voltage and turbidity in national turbidity units. This is the sensor housing where our turbidity sensor will go inside. It is meant to keep our electronics dry and protect them from the harsh marine environment. Our housing is connected to a data cable that can send the serial data through a noisy environment without significant loss. Finally, our measured data is sent to the data logger, where this information is stored, processed, and sent to our users via cellular.
Before Ocean Pulse, I was a nobody. My marine data was hard to come by, and I wasn't getting any meaningful readings to support my research. Now that I'm using Ocean Pulse's subscription-based buoy network, I can feel at ease with the data I'm using to change the world.
Hello, everyone. We are Fusion Sense. I'm Alex.
And I'm Owen.
And we do reliable radar for real-time results. Now, what we're all familiar with is this excitement to get autonomous vehicles on the road today. But what some of us may not realize is that autonomous vehicle manufacturers are in a big dispute over what's the best sensor to use for their systems. Current research is in infrared, LiDAR, pure vision systems, and now radar. Our team believes that radar will be the next and best technology that will dominate this landscape. But why should we study and develop radar systems today? Well, in 2017, the FCC approved radar technology for autonomous driving systems. And shortly after that, the UK's Transportation Services announced a new safety scheme where all the autonomous vehicles on the road had to be networked with each other. Now, it was just this year, in 2023, that the Tesla vision system, using a purely optical vision system, moves to incorporate radar into their autonomous driving framework. So, with this burst in the market for radar technologies, what have we done to approach this gap? Well, meet FusionSense.
FusionSense uses industry-leading hardware in combination with our own custom software to form a low-cost, portable, and easy-to-use research package. To give you guys a better understanding of the data that we can collect, let's jump to a quick live demo.
So here we have FusionSense live on the stage for you, and we're going to be collecting real-time radar data on the screen behind me.
This is an example of a range velocity map. It's what we use to analyze our radar data. You'll notice that as Alex walks away from the board, his distance on the y-axis increases. As he comes back towards the board, his distance decreases. Furthermore, as he moves away from the board, his velocity is positive on the right side of the map. As he moves back towards the board, his velocity is negative on the left side of the map. Now, this is great, but singular radar nodes, such as this one, suffer from a few fallbacks. Notably, they are line of sight only, and they can only detect velocities coming directly toward or away from them. Take this busy city intersection, for example. You'll notice that it has a blind corner. Right now, neither car can see one another. However, with FusionSense technology at multiple spots in the intersection, a complete field of view is formed. By networking them together with the cars, now both know where each other are. Thanks to this, the scene is safer for everybody. To give you another reason why our approach is so powerful, we want to show you another demonstration. Just last week, our hardware team and our software team got into a huge fight. You'll notice that Alex is driving his car straight towards Jackie on his bike. Now, our radar picks up two objects. You'll notice the large car and the small biker. They appear very close to each other on the map. However, since neither is headed directly towards the radar, they appear to have very low velocity. But if we look at another point of view that is head-on, you'll notice that this time, the bike is moving very fast away from us, and the car is moving very fast towards us. Now, using these individually, they can't tell us much, but by looking at both point of views together, we can tell that a near collision is about to happen. Now, thanks to FusionSense, Alex's car was stopped and Jackie left the scene unscathed. Now, working on this project for nearly a year, we realized we had something really special on our hands. We had a low-cost way for researchers to get started with radar, compared to what big manufacturers typically spend millions of dollars on. So, we decided to make all of our hardware, software, and 3D models available to the public. So far, we've seen researchers at the University of Alabama use FusionSense to do American Sign Language detection and analysis, and researchers here at UCSB use it for RF gate detection. We are super excited to see what people continue to use FusionSense for in the future. Thank you for listening.
phone in your pocket contains 15 billion transistors, none of which would exist without one company, ASML. ASML controls 90% of the market for machines used to produce these chips. If they were to disappear tomorrow, all of the world's high-end technology would as well.
The next generation of chips is enabled by ASML's chip-making EUV photolithography machine, an apparatus the size of a school bus, which has also been called the most sophisticated machine ever built by man. All of the major chip manufacturers such as Intel, TSMC, and Samsung rely on ASML's machines.
These machines are capable of producing 100,000 chips per hour. However, ASML wants to increase the production rate of the machine, which will require it to deliver more precise amounts of EUV energy at greater speeds. Because of its size, the sensors used to control this energy are slow and cannot support faster operation.
We made a program that takes advantage of faster sensors which are currently unused, enabling the machine to run at twice the frequency while still maintaining tight control of the energy. We achieved this by making a predictor algorithm that compensates for the feedback delay. Based on our simulations, our algorithm will allow the machine to theoretically increase the throughput by 95.2% without needing to redesign or rebuild already expensive equipment.
It is an exciting time for the field of robotics right now, with robots becoming more sophisticated and more prevalent in our daily lives. The field of robotics, however, can be difficult to get into for new people due to the high cost of some robots, the complexity of coding, and availability of some research. Our capstone team aims to address these concerns by creating Velma, an autonomous vehicle built on a 1/10 scale RC car using resources from the F1/10 community project. Using the map Velma makes as it travels around, the Navigate program allows the user to select a point in the space for the car to navigate to. With the wall follow protocol, Velma travels in unknown space by using PID control to keep within a consistent distance from a nearby wall. In the searching protocol, Velma considers various factors about the environment, such as unexplored areas and ease of travel, to create an efficient searching path to look for the object. In our case, our object is a large orange bucket. Once Velma sees the orange bucket with its camera, it changes its path to navigate to the bucket and stop in front of it.
How many of you guys have heard the saying, take life one step at a time? I've heard it about 1 million times from people, movies. There are even entire song titles dedicated to it. This phrase is supposed to represent the idea of taking on a challenge carefully and deliberately in order to ensure future success. As a child, your first steps are even recognized as one of the very first major milestones that you take towards your independence in this world. But what happens if these first steps become easier said than done? And what happens if these first steps are never taken? Cerebral palsy is a collection of disorders that affect movement control, muscle strength, and posture. What this essentially means is that a person with this condition will find it hard to stand, walk, and sometimes even speak. According to the CDC, 1 in every 1,000 children in the US are born with this condition. I would like you to meet Elizabeth and Elif, who were willing to share their stories with us to help us better understand what it is like to live with cerebral palsy. This is Ellie. Ellie is 24 years old. She loves music, the beach, and hanging out with her friends. You can always find her out on the dance floor at any family party. This is Elif. Elif is your typical 14-year-old middle school student who loves watching anime, playing Pokemon, and talking to people. He hopes to one day become a film editor and have his name up on the big screen.
Currently, the only treatment for cerebral palsy is physical therapy, where a medical professional assists a patient one-on-one with various exercises so that they can gain better motor control. During this process, an environment is created where the brain's neural pathways are trained to compensate for damaged ones. In this graphic, we can imagine that these lines are the neural pathways themselves, and the more they are used, the stronger and more efficient they become. What this means for physical therapy is that the more it is completed, the more effective it is overall for the patient.
So for Ellie and Elif, they participated in a form of physical therapy called ball therapy. Essentially, before being able to walk or use your legs, you need immense core strength. So what you see here is ball therapy. Essentially, as young kids, Ellie and Elif were tilted from side to side by a physical therapist. And while they're being tilted, there's a split second where they're kind of off balance. In that split second, their cores engage and those muscles build up to kind of give them that ability to become more mobile. The problem is this has to be done consistently. So for many families, this might not be feasible. The main things are cost and frequency. If you just can't afford the right insurance or it can't cover ball therapy that much, then you won't go 3 times a week. Or if you have, a busy schedule and you can't take your child to and from a physical therapist's office, then you're going once a month. Imagine if Ellie and Elif got to go twice as much as they did. Imagine if every family could provide care for their children with cerebral palsy and give them treatment every day instead of every month.
And that's where this comes in. This is the BabyBot in motion. As you can see, it emulates the ball therapy treatments discussed earlier by using 2 motors to tilt in various directions. Since our target audience is under 2 years of age, which is the ideal time to start treatment, we have decided to implement the Game Bar, which uses lights and buttons to be an entertaining way for the young patients to engage in their own therapy.
Our goal is to make this form of physical therapy as accessible and as affordable as possible. By mass-producing these devices, we are able to provide care from the comfort of the user's home, meaning that they can receive treatment up to multiple times in a single day. Doing this would eliminate cost, transportation time, and numerous other underlying issues that may pose obstacles towards these families.
BabyBot isn't just a physical therapy device. It's not meant to replace therapists or magically give the user, the patient, the ability to be more mobile. It's the first step. It's an iteration towards progress of medical devices that enable care being accessible and being able to have it more often. It's the first step in giving others their first step. In Ellie, the ability to dance, or for Elif to walk the halls by himself. Hopefully, you join us in seeing this vision. Thank you.
Thank you.
Don't you wish your anterior lumbar interbody fusion procedures could take less effort, be faster, and reduce patient recovery times? Yeah! Introducing the Hermes Expandable ALIF Trial. In the United States, there are over 300,000 anterior lumbar spinal fusions performed every year. Currently, these operations require surgeons to trial and error around 6 different static trials until the perfect size is found, a process which requires multiple devices, a lot of time, and a lot of hammering. With the Hermes trial, the surgeon can adjust the height and angle of the trial mid-surgery by rotating the respective dials on the handle. Once the desired trial size has been reached, the surgeon will then read the handle outputs and use a simple lookup table to determine the size of the implant that is needed. It's really that easy. Just slip the trial into the disc space, adjust to the correct size, and read the measurement output from the handle. This means less hammering, faster surgery times, and an easier recovery for patients. Thanks, Hermes. Just look how happy our surgeon is with his new Hermes trial. Hermes, expanding spinal solutions.
This system can measure the density of an object automatically. Normally, measuring density is done by hand for every object one at a time. This system, the Dragon, changes all of that. It consists of a robot, a true mass scale, a buoyant mass scale, and a part tray that contains each object being measured. It operates by picking up a cage that contains an object and placing it on the first scale, which measures the object's true mass. Then it brings the cage over to the second scale, submerging it in a water beaker to measure its buoyant mass. The scales automatically send these mass measurements to a computer, which uses a formula to calculate the density of the object. All you have to do is simply click the start button, and the robot will measure the density of 23 objects consecutively in one go. Per sample, the Dragon takes 2 minutes to measure density, which is 30% faster than an operator performing the test manually. It can measure parts of any shape that can fit in the cage, and it measures with 1.5% degree of accuracy. Dragon Dynamics. Possibility at the push of a button.
Imagine this. You're driving down a dimly lit road, struggling to see what's ahead. Suddenly, a pedestrian appears right in front of your car. You, as the driver, must now rely solely on reactions to perfectly navigate the situation, because as we all know, the next few seconds can change a lot. For some, this is where automatic emergency braking, or AEB, comes into play. Most modern vehicles use radars and visible light cameras like the ones in your smartphone to help detect and prevent you from these kinds of accidents.
Unfortunately, AEB just isn't doing the job. This technology has been mainstream for over a decade, and yet we've seen zero improvement when it comes to pedestrian fatalities. In fact, it's so bad that 75% of all pedestrian fatalities take place at night, even though only merely 25% of car travel takes place in the nighttime. This is all because of radar technologies, which are limited by distance, or visible light cameras, which require visible light, which we don't have at night. So we can keep trying to build on these technologies, we can push them to their limits, but today, we're gonna show you a whole new take on automatic emergency braking, one that you've never thought of before.
We call this device SafeSight, and today, we are so excited to show you how these eyes will save lives.
Let's see how SafeSight works and why it's so effective. Take a look at this picture right here. Let's get a show of hands. How many pedestrians can you guys identify? Let's get a show of hands for 1 person. 2, 3. What if you don't see any at all? Let me show you a different kind of picture now. See, for your car doesn't see any pedestrians at all. But with SafeSight's advanced thermal technology fused with our cutting-edge AI software, this question becomes much, much more simple. And that's because SafeSight just needs your body heat to create a comprehensive picture of the road ahead.
This discrepancy you just saw is exactly why automatic emergency braking systems are failing in darkness. As a society, we come to rely more and more on these driver assistant technologies to help detect pedestrians for us. However, as you can see, we just can't trust these safety systems, not when they only work during the day. With SafeSight, you can place more trust in your vehicle, knowing that it'll brake when it detects any in-danger pedestrian's body heat.
However, there's one major limitation when it comes to thermal camera technology. Thermal cameras just can't see through glass. So after 9 months of extensive research and development, we've successfully overcome this limitation, and we're able to safely and securely place SafeSight on the exterior of a car. And we've made it so easy that any one of you in this room could install SafeSight on your car in under 30 minutes.
Ladies and gentlemen, let me introduce to you SafeSight. SafeSight is the world's first aftermarket thermal camera pedestrian detection system made possible by proprietary 60 gigahertz millimeter wave wireless technology that we've integrated into the device itself.
SafeSight consists of 2 parts. First, we put our thermal module on the car, outside of the car, on the windshield. Then we complement that with a state-of-the-art computational module that goes inside the car on the other side of the windshield. Once you've made this installation, these 2 modules will wirelessly communicate with each other and wirelessly power each other seamlessly to get thermal data to the car and driver.
SafeSight is built for all sorts of driving conditions, whether it's bumpy roads or in the rain, and we worked with an industrial design artist to make sure that SafeSight seamlessly blends in with vehicles on the road today.
This is what SafeSight looks like on a real car, and again, we've made it blend in with any vehicle. Finally, let's see SafeSight in action. Again, on the left, you have your visible light camera. Again, that's what your typical car sees if it has automatic emergency braking. On the right, we have SafeSight's advanced thermal vision technology, and you can clearly see the difference. SafeSight can identify a pedestrian much more quickly, much more accurately, much more effectively. But just for maximum effectiveness, SafeSight actually takes both of these technologies you see here, and it uses our Prism AI program to fuse it together so you get protection at all times of the day.
Now, if I could have your attention one last time, audience. These automatic emergency braking systems, equipped with visible light cameras, have been around for over a decade now, and yet we still have seen a ton of 75% of pedestrian fatalities happening at night, despite only 25% of vehicle travel taking place after dark.
And that adds up. That's over 6,000 deaths and over 100,000 serious injuries every single year.
Clearly, these AEB systems are just not getting it done.
And that's why we made SafeSight.
The eyes that will truly save lives.
Thank you guys so much.
Imagine you need to inspect this industrial facility. Currently, you need to break apart its long pipes into smaller sections so borescopes or rovers can be used. At Apical Robotics, we worked to improve industrial inspection using a large-scale soft robot known as a vine robot. Vine robots are pneumatically powered mechanisms that grow and retract like a vine through their environment. Because vine robots have never been built at a large scale, making one at the required size was a major challenge. To do so, we needed to create a novel model to go from a given pipe system to critical robot parameters. We then had to solve many design challenges with numerous mechanical, controls, and communications systems. Here is our final design with the numerous support subsystems, a main pressurized body, and a sensor mount. And here, it has grown to its full length of 110 feet. We first tested our robot at UCSB in preparation for a demonstration to our research partner, Bechtel. We then shipped our robot to a Bechtel facility in Houston, Texas. At this facility, Bechtel had constructed a pipe 3 feet in diameter with a 60-foot horizontal and 20-foot vertical section. Just the pipe material alone cost Bechtel $20,000. To begin our demonstration, the Vine robot was placed into the entrance of the pipe and grown forward. The Vine robot then exited the pipe in only 16 minutes. Here is a wide shot of the Vine robot exiting the pipe and then getting retracted back through the pipe. We were also able to use the Vine robot to lift a heavy plywood board, which might be useful for tasks such as clearing blockages. And here, we were able to see the live, high-definition video the Vine robot collected from inside the pipe, which allowed us to clearly make out the rust and small features in the pipe walls. We also explained our robot to Bechtel R&D engineers, and here is what a Bechtel construction manager had to say.
Very interesting to see how it works in person and the real-time data that you were able to collect so you can make the proper adjustments. I think this is a big success today.
Lastly, members of our team entered the UCSB New Venture competition and won various awards. With the success of our project, we believe we are now one step closer to revolutionizing industrial inspection.
Hey guys, it's Joey from AlignMate. Are you tired of your PCBs not aligning perfectly to your metal frames? Well, Northrop Grumman has this problem and is losing money by not keeping up with the times. Behold the power of the AlignMate Precision Alignment Tool. Guys, this thing will seamlessly align your PCBs to your metal frames, easily, quickly, and most importantly, accurately. Made from high quality and high precision parts, this thing will change the way that you align forever. All right, let's do a run through. Now you need to pay close attention because this thing works quick. First, we need to put our metal frame in there. See how easily it slides into position. I mean, guys, it's so easy. I don't even have to look and I can do this. Now the tool constrains all 6 degrees of freedom, so our frame slots in perfectly every single time. All right, guys, now that our frame is aligned, we don't have to worry about it for a while. Out of sight, out of mind. Now let's get our PCB in on the action. Let's just lay it on top of the frame. Now we'll lower our dowel pin and add our micrometer and preload. We're only a minute in and ready to align. Check out our custom software that applies a reticle overlay on our monitor. It lets us quickly check for alignment using the eye test. Now check this out, guys. Simply spinning the micrometer allows us to clock the PCB around the datum hole. I mean, how cool is that? Now with these zoomed in views, it'll be harder for you to leave with a misaligned board than an aligned one. All right, once we're all set, all that's left to do is screw our board in, disengage our preloads, and pull our assembly out. Now this thing is ready to get slotted into your chassis and sent off to space. I mean, it sells itself. But wait, there's more. Camera's not calibrated? Check out how easy to use our custom calibration software is. You'll have a fully calibrated camera in 2 minutes flat or your money back. But wait, there's more. Say you have a massive PCB, one much bigger than we have here. Well, no need to fear, we've thought of that. Check out our linear rods. See how they span the entire length of the tool. We can catch your frame wherever it might end. No recalibration necessary. All you gotta do is sit back and relax. But don't just take it from me. See what our satisfied customers have to say.
Wow, AlignMate is a lifesaver. This thing is awesome. It has saved me so much time and energy, and I cannot get enough of it, let me tell you.
Right now I'm working, 50, 60 hours a week, pretty much every week, just aligning PCBs with our current tech. Work-life balance is not good. Like, been pretty happy recently. And then, here comes AlignMate. And damn, this thing is good. We're at 2-minute alignment time, completely robust, and it's adjustable for different boards. Yeah, that's a lifesaver, I gotta admit.
Not satisfied? What if I told you that this thing is accurate to 3/10,000ths of an inch? Guys, that is small. That's precision alignment for mission performance. This thing is ESD safe, color-coded for use, and everything you see here is easily adjustable with a couple turns of a hex wrench. These things are going quick, so get your order in now. To buy, call us at the number shown on your screen. If you call in the next 20 minutes, screw it. I'll throw in another one half off, plus an extra frame and board that your kids can play with. I mean, come on guys, I'm being too generous here. That's a $10,000 offer for just $3,000. I mean, how could you not get this thing? Call now, and you're going to be calling this tool your best mate after you use it once.
Thanks, Matt. All right, so now is the time to vote. So if you just get your phones out, point at the QR code on the screen or on the little QR code on your program itself, you should get to the voting app. And we'll let you guys do that over the next 10 seconds or so. While you're doing that, I would just want to explain a couple things. So we're going to announce all the awards. First, the awards from the judges, and then we'll be announcing the awards as you voted. One thing to note is if you win an award, please stay in your seats. We will invite you up at the end of the show for you to get pictures up on the big stage. It'll be a lot of fun. So for the audience, just give them a clap for about 2 seconds, and then we'll stop, and then we'll go to the next one. So I want to introduce Professor Alon Ben Yaakov of Electrical Engineering to give us the first awards. Oh, I can't hear that.
Can't hear. Does this work?
Can we get the handheld mic?
For electrical engineering, we have 3 awards to give.
Okay.
These were voted on by judges based on presentations a couple days ago. The awards are Outstanding Innovation in Electrical Engineering, Distinguished Technical Achievement in Electrical Engineering, and our top award, the Excellence in Electrical Engineering. And each of these come with a monetary award listed up here. So let's start out with Distinguished Technical Achievement in Electrical Engineering, which has a $1,500 award. The team that won this created a novel control system for improving the output in creating computer chips, and that is ASML Control Sense.
Alon, your mic's on now. Your mic's on.
Is it on now? All right, there we go. All right, congratulations to ASML Control Sense. So for our outstanding innovation in electrical engineering, the team that won that award you saw earlier on stage with their radar system for autonomous driving, and that was our MIMO Fusion Sense team. Congratulations, Fusion Sense. And our top award in electrical engineering, the Excellence in Electrical Engineering, goes to a team that created a novel system for detecting firefighters during the peak fire season here in California, and that's Line Alert. Congratulations, Line Alert.
Okay, in mechanical engineering, our distinguished technical achievement in mechanical engineering goes to a team that had just ultra precision, below 1,000th of an inch in aligning these boards to the frames. You just saw their video. That is Northrop Grumman alignment. Next is the outstanding innovation in mechanical engineering. This team created probably the largest robot ever made in the world, we think. We don't have anything to back that up, but it was about 150, 130 feet long, something like that, right, guys? That's Apical Robotics. And finally, the top award, $3,000 check, goes to the Excellence in Mechanical Engineering Award, a team that created a really revolutionary device that could go inside the body and measure a gap inside of the spinal column. That's C-Spine Herman. Do you want to do the honors?
So finally, we have our award for our multidisciplinary teams. So within our capstone program, we have
typically have smaller 5-person teams in each of our disciplines, but then we do larger multidisciplinary projects. And you saw presentations from each of those teams up on stage earlier. And so for our top multidisciplinary team, we give the award of Excellence in Multidisciplinary Engineering. And this year, the award went to the team that won the Navy Robot Rodeo competition, and that is Gainer.
Okay. Thank you, Alon. All right, so now your choices. Who'd you pick? This is being done live as we speak. They're going to bring out the checks based on the poll. Best electrical engineering video that you chose was, can we see this, Alon? Amped. Best mechanical engineering video is C-Spine again with the Hermes. 2 wins for C-Spine. And the best pitch in $1,000 for your favorite presentation goes to Navy again. Cleaning up, cleaning up. Okay, we got one last surprise for everybody. Dr. Ben-Yaakov and I wanted to do something special for this class that's graduating and everybody that comes to these shows. We appreciate you. So we reached out to a very special person to give us a little bit of an address. This is a former NASA astronaut.
Hello, UCSB Engineering Capstone class. This is former NASA astronaut Terry Virts, and I've got a request from Professor Susko and Professor Ben-Yaakov to tell you guys congratulations. So congratulations on a job well done. I know getting an engineering degree is very tough. I started out as an astronautical engineer and ended up as a math major because I didn't want to do all the coding. So I know firsthand how tough it is. I did not finish that part of my college. But you guys have done amazing stuff. I'll tell you right now, in America, we need engineers in mechanical, aerospace, aeronautical, electrical, whatever it is. Lots of companies have a really strong need for American engineers, not only to do classified defense work, but even the unclassified, civilian work. There's a lot of really cool opportunities right now. So you guys are graduating at the right time. I've seen the list of companies that many of you are going on to work at or grad school. So just keep up that good work. I'll give you 2 pieces of advice. For my career as an astronaut, I had a chance to fly on the space shuttle as Endeavour's pilot on the last space station construction mission, and then I went back a few years later on a Russian Soyuz for 200 days, ended up being the space station commander. And so the first piece of advice that I have is don't tell yourself no. If you've got a dream, don't tell yourself no, you go for it, but you have to tell yourself yes if. If you want to be CEO, there's a lot of things you have to do. You can't just say you want to do something, you have to come up with that step-by-step plan to get to where you want to go. So that's my first piece of advice, don't tell yourself no. And the second piece of advice is you guys have a great head start with a college engineering degree, but it's not going to cut it for your whole career. That'll last you for your first 5 years, and then you're going to need to learn more, and technology is going to change. And if you ask professors or industry people who are retiring now if what they learned in electrical engineering classes apply, obviously it doesn't. So really a lifetime of learning for me. I'm still learning new things. I'm directing some films now, so I've been learning how to become a director. Very different than my technical test pilot astronaut career before, but I love it. Even writing books, I've written a few books. I was probably the least likely to write a book, but I've learned how to do that, and that's been a lot of fun and fulfilling. So keep yourself open for a lifetime of learning, not just technical classes, but even at work. Be eager and learn new things at work. Bosses will like that. Bosses will like it if you bring them solutions and not just problems. So think through things like that. But congrats. It's a big step right here. Thanks to your professors for setting this up. And go make America proud. We need you guys out there in the workforce. We'll see you later. Bye-bye.
To all the teams that completed their capstone projects and are now graduating, you guys did amazing work this year. And before we go, we couldn't leave without a thank you to everybody who helped out along the year. So this really takes a village to make a program like this happen. And so to start with, I'd like to thank all of our project sponsors who provide us with project ideas, with technical support, with funding for our program. We couldn't make this happen without you, and we deeply appreciate everything you do for our program. We'd also like to thank our faculty advisors and our TAs who meet with our teams every week and work with them to help guide them and help develop their products. Again, we couldn't do this without all of the support that you give to us. So up here we have all of the electrical engineering faculty and TAs who've helped out throughout the years, as well as several, John Jacobs and Paul Hoff, several mentors who have come to us from industry and show up every Friday and meet with our teams. We're deeply appreciative of all the help that you've provided us, so thank you.
And lastly, the sponsor or the advisors from mechanical engineering, they meet just like Alon's group in ECE. They meet with the teams weekly all year. And without them, this program wouldn't be anywhere close to where it is. We also have our TAs on here, and Amanda Hart, who makes it possible to order all the stuff that we order all year. So thank you to everybody. And that's it for the showcase. Thank you so much for coming. We hope you enjoyed it. Students, come get some pictures.